every one of these ones we can check with our calculator, right? And if you forget how to put something into your calculator, like, you know how you have sine, cos, and tan buttons, but you don't have secant, cosecant, cotan buttons? This is where our unit circle and formula sheet come in handy for us, because these three things right here, cosecant, secant, and cotan, they tell you how, using the three buttons we do have on our calculator, sine, cos, and tan, how we can type them in. Like, it literally tells us what to do, right? So if it's cosecant is 60, it would be 1 divided by sine of 60 in my calculator. Right? So this tells you exactly how to type them in. Because people get stuck and they're like, I don't know how to do it. I'm like, the formula sheet shows you the way. You know? All right. So sine of negative 300. We can rotate negative 300 and look for the terminating arm. Or we can add 360 and get the coterminal angle. So this would be the same as sine of 60. What's the answer to sine of 60? 3 over 2. Now, when I check these, do I want to put sine of 60 into my calculator, or do I want to put sine negative 300 just in case I messed up? Always the original, right? So everyone's trying it out. Sine negative 300. I go to press the sine button. I slap my hand and I say I need to be in degree mode. So whenever you go touch one of those buttons, no, stop. What mode do I need to be in? And you get 0.8660, which we know is your root. Okay? Secant of 60 is besties with what? Secant's besties with what? Cos of 60. It's just a reciprocal trig identity of cos of 60. So what is cos of 60 the answer to that? 1/2. So what is secant? 2. 2 over 1. Now let's check it in our calculators. Are we paying attention? Put it away. Put it away. Put it on your binder. Put it away. On your binder. On your binder. Under your binder. Stop it. No. I'm going to take it a couple of... He's literally totally all right. All right. Secant of 60. How do I type it into my calculator? Exactly. Yeah. 1 divided by cos 60. So here it says secant equals 1 over cos theta, right? So type in 1 divided by cos 60. Everyone's practicing. It's just because the person beside you can do it doesn't mean you can. That's how it works. And you should be getting an answer of 2. Are you? Yes. 1 divided by cos of 60. Okay. Okay, cos 150. What is x at 150? What is x at 150? Negative root 3 over 2. So now type in cos of 150. We're checking these all out. We're practicing with our calculators. Cos 150. And you should get negative 0.8660, blah, 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 right? Sine 315. Sine is the y at 315. So the y at coordinate at 315 is the answer to sine 315, right? We know that. So sine 315 is negative what? Root 2 over 2. Sine negative 30, we can either picture it, wow, that is not straight at all. That's brutal. We can either picture it here going negative 30, correct? Or I can add 360 degrees to it, and it would be the same answer as its coterminal, which is sine 330. So what is y at 330? Negative 1/2. Okay, then I get tan of 240, and people have stuff just follow their heads, like I don't know how to do that. But if I go look at the very top of my formula sheet, not the one that's the weird off formula that we're going to talk about tomorrow, the theta equals A over R, but the top two above the three that show you how to type into your calculator. So the top two below the theta are ones that tell you how to use the unit circle to get you tan and cotan, correct? Because on your unit circle you have cos and sine. So secant and cosecant are easy, they're just a flip of it. But cotan and tan come from those top two formulas. So if it's tan of 240, I could rewrite that as not tan 240. That would be just rewriting the same thing. It's stupid. I could write sine 240 degrees over cos 240 degrees. What is tan of what is sine of 240? Sorry. Negative root 3 over 2, and cos of 240 is negative 1/2. Did you know that when you have stacked fractions, everyone's paying attention because it's important. When you have stacked fractions, if you have things that are similar in the numerators of them, you can cancel it off. If you have things that are similar in the denominators, you can cancel them off. So for example, these two 2's can go away. Now the reason why that is, I'm going to show you why, and then after that you don't have to show why. But it's because negative root 3 over 2 divided by negative 1/2, I could write sideways, which is negative root 3 over 2 times the reciprocal, 2 over 1. And so I get, sorry, negative 2 was, so I get root 3, right? It's because of the reciprocal and multiplying that if you have denominators that are the same or numerators that are the same, you can cancel them when you have stacked fractions, okay? So here I have negative root 3 divided by negative 1, which is just root 3. Now if you go tan 240 into your calculator, let's go, tan 240 will give you a decimal. Then you're going to type in root 3, it'll give you a decimal, and hopefully they're the same. I think it's like 1.7 something, isn't it?
Yeah, 1.73.
Yeah. Okay, tan of 480. 480 is on our unit circle, but it's a lot easier if we find its coterminal, correct? So I'm going to subtract 360 from it, and I'm going to get tan of 120. So I'm going to get sine 120 over cos 120, because my unit circle gives me those values. What is sine of 120? It should be negative root 3 over 2. Positive. And then cos is negative 1/2. The 2's cancel. My answer is negative root 3. Because it's in quadrant 2, it should be negative x positive y. Oh, wait. 225. X at 225 is going to be negative. Negative what? Root 2 over 2. And then I'm going to square it. I square a negative, it goes away. I square a square root, it goes away. So I'm left with 2. And then 2 squared is 4, so I get a 1/2. Now some people will say, why did they put the squared in the middle? Is everyone paying attention? Because I'm going to ask people ask me this, and in calculus they do the same when we do derivatives. We need to pull the 2 out. We do chain rule. But they ask, why is it there? Because if it's back here, that means this is squared. And I'm not squaring the 225. I'm taking the whole answer and squaring it. So they figured out the way that they're going to show that is they put the 2 in the middle. Now you can't, no matter how hard you press your button on your calculator, you can't go cos and put the 2 in there. Because the moment you press cos, it opens a bracket, correct? So you can't go cos squared, open a bracket, put 225, because it opens the bracket. So the way you have to type into your calculator is you have to go cos 225, hit enter, and then squared, or brackets, cos 225, and squared outside. Okay? Sine 5 pi over 3. What is y at 5 pi over 3? 5 pi over 3 is the same as 300. What do we get? Negative 300. Now when I go to type sine 5 pi over 3 in my calculator, what do I have to make sure? It's in radian mode. Okay, tan of 7 pi over 6 is the same as 210. So we really want to write tan again. Sine of 7 pi over 6 divided by cos of 7 pi over 6. What is sine of 7 pi over 6? Cos 7 pi over 6? Now these cancel, and I'm left with 1 over root 3. What do I still have to do? The denominator. I get root 3 over 3. Okay, we have cos of negative 2 pi over 3, which is lovely. We could visualize it. We could actually go backwards with it. Or I could do what? Add 2 pi. Remember, if you want to type it into your calculator, not make common denominators, you'd have to go negative 2 divided by 3 plus 2, and then add the pi to the top. So let's go. Negative 2 divided by 3 plus 2. And then convert it to a fraction. What do we get? Cos of, pardon? 4 over 3. And then I just have to add my pi back. We agree? Now 4 over 3 is nicely on my unit circle, is it not? Yep. So what's cos 4 pi over 3? What's the answer to that for x? Now I would check cos, I would go in radian mode, I go cos negative 2 pi over 3 and get that and make sure it's the same answer, right? I wouldn't put 4 pi over 3 in, because what if I made a mistake? Okay? You guys try these last 3, if you haven't already, and then I want you guys to do this one, and this one. Okay? Example 5, 6, and 7. So finish these 3 if you haven't, because I know I see some people don't have them done. And then 5, 6, 7. Now we're going to go through them. Sine of negative pi, you can either follow it to negative pi and know that it's here, or you can add 2 pi to it and get its coterminal, which is sine of pi. Same thing, what's y at pi? What's y at pi? 0. Cos negative 5 pi over 3, we can add 2 pi to that if you'd like. We would get cos of pi over 3. And what's cos at pi over 3? 1 half. Yeah. And then we'd have to go sine of 2 pi over 3 divided by cos of 2 pi over 3. And then square it. What is sine of 2 pi over 3? Root 3 over 2 and cos? Negative a half. Squared, these cancel. I'm left with negative root 3 squared, which is? Okay. Then we're going to flip over. All right. So these ones, I want you to just tell me what they are to 4 decimal places. Sine 1.92 has to be in radians. What is this? 9386. All right. Tan negative 500 has to be in degrees. What do we get? Secant, if I don't know how to type in secant, I go to my formula sheet and it says 1 over cos of whatever the angle is. Has to be in degree mode. What's 1 divided by cos at 85.4? Cotan of 3 is the same as 1 over tan of 3. Has to be in radian mode. What do we get? And then sine of 5 pi over 12. All right. The next one here says angle theta is in standard position with a terminal arm in quadrant 2. Perfect, quadrant 2. Bow tie, always, right? So we always draw bow ties, so it's always towards the x-axis. The terminal arm has a length of root 29, so that's a fancy way of saying the radius is root 29. Contains a point x equals, and I'm going to go negative because I drew it, so I know it's negative. and then y equals 5, and then I need to find out what x is. So x squared equals root 29 squared minus 5 squared. X squared equals 29 minus 25. X squared equals 4. Square root plus or minus. And because I drew it, I know it's negative 2. And then cotan is the opposite of tan. So if tan your x box, cotan would be x box your. So it's going to be negative 2 over 5. So that's another way they could give you a coordinate, give you the radius somehow, and then have to find x, right? And then this one, find cos. So we'd have to get our x equals 5, y equals 12. We have to get our, that is 15. What the heck? X equals 5, y equals 12, r equals 13, I believe. 5, 12, 13 often goes together. And then 3, 4, 5 is another one that often goes together. So you cook extra rice. Suppose theta equals 5 over 13. Now I want you to determine theta. What is theta? One decimal place. So we have cos theta equals 5 over 13. If we want reference theta, wow, keep going. Sure, of course. We use cos -1 of the positive. What's the cool thing about this one who's in quadrant 1? The reference angle is theta. It is the angle. Quadrant 1's reference angle and theta are the same. Yes? So what do we get? Pardon? All right? You agree? Okay, grab out a separate sheet of paper. The next 20 minutes, we're going to do homework questions together. Let's go. So when we get a long weekend, we can actually have a long weekend. And if you so choose to study trig and polynomials, you can. But everyone needs a break at some point in their life. No, these will appear nowhere. You're going to do work instead of me giving you a homework. All right. So the first question I'm giving you, given negative 3, 5, determine the 6 trig ratios and the value of theta when theta is between 0 and 2 pi. So if you give me an answer in degrees, how many marks you get? 0, because it's in radians. Yeah. Okay. What's the first thing I need to do? Label my x and y and then draw it. So I have negative 3 and 5. So I know I'm here. X equals negative 3, y equals 5. And when I get my reference angle, it's going to give me this. Correct? So I'm going to go 180 minus that. By drawing, it's so important to figure out where the heck it is to get that coterminal. Or to get the principal angle, sorry. So r squared equals 5 squared plus negative 3 squared. R squared equals 25 plus 9. R squared equals 34. Plus or minus the square root cancels. Plus or minus the square root. 34. Does it reduce? Yes or no? No. So my 6 trig ratios, if I go sine theta, Sign your resume. So I get 5 over root 34, sorry. And when I rationalize that, I get 5 root 34 over 34. Sign's bestie is cosecant. So if it's sign your resume, it's resume your, which is root 34 over 5. Which makes sense that they're both positive. Why are they both positive? What quadrant am I in? The second quadrant, and the things that are positive in the second quadrant based off of cast is sine and its best friend cosecant. Your other 4 trig ratios should be negative. Okay, then I have cos theta. Cook extra rice. So I get negative 3 over root 34. Rationalize. Negative 3 root 34 over 34. Best friend of cosecant is secant. Guys. All right, root 34 over negative 3. Now paying attention, they can give it like that. They could give the negative in front. Or they can move it right to the top. As long as there's only one negative sign, right? When you divide them all out, you're still going to get negative the same decimal, right? No matter how you do it. Okay, tan theta is tan your x box. So I get 5 over negative 3, or negative 5 over 3. And then cotangent is x box yours, so it's negative 3 over 5. If I'm picking a reference theta, I'm going to pick tan or cotan because they don't have roots. But could I pick any of the 6? Yes. Reference angle, you always take the positive of it, so it lands in quadrant 1. Correct? So I'm going to go tan theta equals negative 5 over 3. I'm going to find the reference angle from that. Reference theta equals tan neg 1. Whenever you press second tan, second cos, second sine, that's how you get an angle. Correct? If you're pressing sine, cos, or tan, you're getting an answer. Second sine, second cos, second tan, angle. That's how you do it. You get rid of the tan off it. So tan neg 1 of 5/3. And what do we get for radians? Because that's being radians. What's tan neg 1 of 5/3? 1.03. And that's in radians. Okay? That is this. Yes? I need this. So what am I, instead of going 180 minus that, it's in radians. So what am I going to do? Pi minus that. Right? And what do I get? Pardon? To nearest tenth? Or 2.1. 2.1. So theta equals that. Okay? I'll come back to this answer in a... Yeah, so the second one we can do is, instead of me giving you a coordinate and asking for the 6 trig ratios, I could give you a trig ratio and ask you for the other 5, right? And ask for the rotational angle. So that's another way I can ask it. Instead of giving you, so when I give you a coordinate, I only give you an x and a y. When I give you a trig ratio, if it's tan or cotan, I'm giving you an x and a y. It's the same as giving a coordinate. But if I give you sine, cos, cosecant, or secant, then I'm giving you the radius and you have to find the other side. So, what if I do this? Oops, I already have to change. Being nice because they don't stay between 0 and 360 very often, or 0 and 2 pi. They're often a different one. But even if I asked for it between like negative 360 and 0, you would still find between 0 and 360 and then just get the coterminals. So try this one out.